Good morning.
Good morning.
Maybe we can just wait a little bit until maybe some more folks show up.
Sounds great. My demo isn't as ideal as I want it to be anyway, so maybe in the next 3 minutes I can figure it all out.
Sounds good. All right, so whenever you're ready, well, thanks for joining. I think you're might be the only one, but we record this call, so we'll make it available on the public CNCF TAG-Runtime channel. And yeah, happy to hear about the Cure project and your demo or anything you want to share.
Okay, cool. That sounds great. So I'll introduce myself briefly. My name is Jack Francis. I am a software engineer at Microsoft working in the Kubernetes ecosystem in Azure. And I have been a CureD maintainer as part of that community for, I guess, a year or so now. The project was originated out of the company Weaveworks, but from the very beginning was an open source project. And so maintainers have kind of spanned different companies. So it's not an accident that someone like me working for Microsoft with an interest a while back in evolving CureD to a certain feature area was able to contribute fairly quickly and get to know the existing community and become a maintainer. So is it possible for me to share screen?
For sure, yeah.
Oh, looks like I am sharing my screen. Am I sharing my terminal or?
I think you are sharing your full screen.
The full screen, including the terminal?
Yes.
Okay, cool, that works. So really quickly, I will, let's see, drag over this so we can just show off the landing page. So at present, CureD is sponsored by Weaveworks, and the project is hosted in their organizational repository. The overview of what the project does, it's like sort of like a Unix tool where it does one thing. It's dedicated to doing one thing and one thing well. That's been the sort of operating ethos. And what it does is it looks for a well-known Sentinel file on any underlying OS that is running a Kubernetes node. And it looks for the Sentinel file var run reboot required. And if it finds that Sentinel file, then in a Kubernetes idiomatic way, does the work necessary to reboot the underlying machine or VM OS and essentially freshen that node, or for whatever, there are lots of reasons why a node or an OS might need to be rebooted. A really common one is getting new patches or other OS updates that require a full reboot to properly apply. And to do this in a Kubernetes safe way, so Kubernetes has all these node primitives that allow you to gracefully evict workloads, cordon a node so that it doesn't get any additional workloads scheduled onto it, and then do maintenance work on it. So Kurd automates this. So basically, I'm doing a sort of long explanation, but the TLDR is, if in my cluster, one or more nodes needs to be rebooted, Kurd, assuming that the node reboot requirement is identified in that well-known location var run reboot required. This is actually configurable in Kurd as well, but I'll just speak to the sort of nominal case. So when Kurd observes that one or more nodes need to be rebooted, it takes an exclusive lock against one node at a time to ensure that we don't take out too many nodes at once. And then it essentially makes forward progress through the nodes. And then for each node does a cordon and drain. So make sure that any workloads running on that node go to another node. And then it does a reboot, and it waits for the node to come back online ready. And then it uncordons the node, allowing new pods to be scheduled onto it, and then removes the exclusive lock for that node, and then moves down the list to any next node that also needs to be rebooted. And it does that automatically. And there are sort of expected features around this, like you can set certain day and time periods when reboots are permitted. You're able to configure how frequently you check for reboots. There is a fairly decent sort of flat structure feature set, but the gist of it is that scenario that I just outlined. And so go ahead. Do you have any questions, Richard?
Yeah, that makes sense. Yeah, so the use case sometimes maybe some of the nodes are being upgraded, or in terms of like the operating system, or is that like
yeah, that's the use case I was going to demo. I mean, there are sort of several reasons you may want to do it. But that's, I think, the canonical scenario. So is that an appropriate amount of background material to then just go into a live demo?
Yep.
Okay, cool. So I have got a cluster here, and I will make this a little bigger so posterity can read it more easily. Let's see here. Okay, is this coming across okay in terms of text size?
Yeah.
All right. So I've got, I'm running an AKS cluster right now. So this is in the cloud in Azure. And there's a lot of information I just blasted onto the screen there. But the important bit of information is that at the top, these first few nodes, which are the oldest nodes, are updated to a kernel version that has in the middle this 1089 marker. And I've recently, I built this with Cluster API, and I recently scaled one of the node pools out to 20, and that one is this pool 3. So I'm going to start highlighting here. So if we highlight all of these nodes, you can see that with the exception of this one at the very bottom, that's actually a pool 4. But all of these nodes are running 1086 version of the kernel. And I'll sort of just give away some of the story here. In order to apply that new kernel, I'm going to have to reboot the underlying OS on that VM. Yeah. So I'm going to do something manually, which you would normally in an environment like this have automation around. But I'm going to basically go and pick a few of these nodes and update the kernel, and we can watch how those updates are essentially applied by Kurd. It's not it's not strictly true. What Curity is just doing the one thing, which is to reboot the node. But in a normal situation, I'll just walk through it and it should become clear. So let me, again, make this bigger. And I'm gonna use this one too. Okay, so.
Can I interrupt for a question? So
Please do.
yeah, so you're using AKS.
That's right.
AKS also has no pools, and I think don't
That's
they
right.
don't they actually manage that already? But then, does this integrate with that, or this would be like something independent from that?
That's a good question. Yeah, the AKS demo is more based on the fact that it's sort of easy for me to scaffold a cluster at scale because I work in Azure, and so
Yeah,
I've got all the special powers to do that. But CureD has nothing really specifically interesting about AKS. The CureD works with vanilla Kubernetes, so as long as your cluster is running Kubernetes, CureD will work to its intended effect. At present, AKS doesn't, so it would be possible for your managed provider to do something like CureD behind the hood as a kind of first-class feature of the managed service offering. AKS doesn't currently do this in the exact way that I'm describing. And so this is using CureD allows you to be a little bit more flexible for anything that would require a reboot. It's possible that various managed providers have sort of very specific node upgrade contracts that they fulfill. So like maybe every week they do some kind of background update, which gets provider specific updates. Perhaps it updates to a new version of Kubernetes.
yeah.
So that's sort of separate.
With, sorry, so I'm familiar with like EKS a lot because I work with it a lot, and basically what they do is just for the managed node groups, they show you a flash on like on the UI or maybe the API, and they say like, we have a new version of the kubelet available. Do you want to upgrade? And basically you just click the button, and basically I think they reboot the node, right? Like yeah, they do like a, maybe I don't know what they do in the back, right? So they have a mechanism, but I guess if you have like pod disruption budgets, then that would actually take into effect too, right? But I don't know. I mean, I'm just I'm trying to make some correlation between this project and maybe what EKS has, but I think what EKS doesn't do is the, maybe like if you need to do some minor updates to the node that are not necessarily part of the Kubernetes versions, then this will be more useful, right? Like maybe the kernel version or some patches, right? Like you mentioned before.
Yeah, I think that's right. So for example, you mentioned updating the kubelet. That actually doesn't require the node to be rebooted. It would require the node to be, I don't want to get in trouble by saying it would definitely require, but a best practice would be to cordon and drain the node before you do that operation. But you could actually do a kubelet update in place, and there are all kinds of things you could do in place. And again, it's not fair to say that the exclusive use case is to update a node. CureD really is just concerned with rebooting a node, but by and large, the reason that you would need to reboot your node, the reason that your underlying OS would have that var run reboot required tagged, is because some sort of integral change had been applied to the OS that needed a reboot in order to update it. As we're familiar with, updating our laptops and all that same thing. So it is, I think it's fair to say that in practice, that's what almost everyone is using CureD for, is to make sure that nodes are safely moved forward when reboots are required in an automated fashion.
Yeah, makes sense.
Let's see, let me actually just close that altogether and then just turn off notifications so we don't see this for all time. Cool. All right. So again, we've got 5 or so nodes on the 1089 kernel version and a bunch on 1086. So I'm just going to use a, I'm going to basically create a privileged container into these nodes and do this manually. It's not super fun, but we will start to see interesting things happen here. So I'm going to create a watch on these, and I'll clear my screen so we can have a slightly clearer view of what's happening. And then I'm just going to run this and exit out. And I'll go to another. So I just ran an unattended upgrade and sent it to the background so I could more easily make forward progress. Okay. Okay. I hope that updating, exiting the pods isn't okay. It looks. Wonder if that.
You're trying to evict some of the pods.
Well, I just wonder if I'm maybe if I'm exiting out of the pod, it's actually killing the unattended upgrade in progress. Let's see what the logs look like here. So this is the actual pod that I was execing into. I wonder if it didn't run. All right, let me try this again. So normally I'm trying to do something manual that suggests what would be happening in the background over a long period of time. So
got it.
Your EKS or AKS or your bare metal environment might have like a daily unattended upgrade schedule. And so like in the middle of the night, you might run this on your nodes, and in the morning you come in and then all your nodes need reboots. So with CureD, when you come in the morning, all your nodes will have been rebooted and your kernel would have been automatically updated, and it'll do so in a graceful way, sort of a rolling upgrade through all the nodes in your cluster, making sure that workloads can be gracefully evicted and migrated and then migrated back. Oops, I'm gonna delete these for now. And actually, I don't think I need to even worry about deleting these. Let me go back here. Okay, so let me just run this and we will do the painful thing and wait. So I'm on the host ending in 2. I wonder if this is actually. Okay, well, that did not trigger this. So let me do this the very manual way. So we're not going to see the
file, touch the file. Yeah.
Yeah, exactly. We're not going to see the kernel update, unfortunately. But what I can now demonstrate really quickly is that CureD has observed that that change. And let me quickly hop into demo another key feature here. So I'm going to go to 3 again, and I'm just going to touch this as well. And what we'll see here is if I look at the log at the pods, so the CureD pod scheduled to, I'm going to manually spot this, scheduled at 2. So this is this one. So this should say in its logs, it's been running for a while, so the logs are going to be chatty. But if we go to the bottom, it should say that it's rebooting. Actually, it's offline because it's actively being rebooted. So let me quickly catch the one for 03. Here we go. That's this TV one. So this will tell us that a reboot is needed, but I don't have the exclusive lock. So
Mhm.
This kind of demonstrates the real value proposition of Curity. It's easy enough to reboot a node, but the reason why this project was created in the first place was to sort of fulfill the set of Kubernetes operational primitives that allow this to happen in a Kubernetes native way. So shortly after this is configured to run every 15 seconds. Normally, so you can see this log message at this when it started. Normally you would run this less frequently. That's fairly
Yeah.
often, but
So how does the lock is on who holds the, or which entity holds the lock?
it is I should know this off the top of my head. Let me find out if I can
I'm just
read through the
curious.
code really quick. Yeah, no, it's an annotate. I think it's an annotation against the daemon set. Actually, let's see, kget, because that's a sort of integral thing.
Oh, okay. Yeah.
So let me look at this. Let me just get the whole thing actually. Okay, so let's go up here. Here we go. So it's an annotation against the daemon set. So essentially, I could read through the code. I could like walk through the code and describe it exactly. So this will be sort of maybe 80% true. But essentially every time Curity notices that a node needs to be rebooted, it sees if there's a lock here. And so in this case, it sees that there is a lock because this annotation exists. This is a well-known annotation key. And at that point, it would introspect if I am the one holding the lock. Am I this node? It's not going to do this at the beginning of the process. So at the beginning of the process, it's only going to even consider making forward progress when there's no lock held. And it will then reserve the lock, and then during reboot, it uses the when it's sort of like finishing the sort of whole transaction, it verifies that itself, like the the curd pod running on that node, let's say in this case this 3 node, if it's holding the lock, then it goes through the process of validating that the node is coming online and then releasing the lock for a future node to reserve it. And then all other nodes that need to be rebooted, Curity will notice that right away, and then essentially put the process into an inner loop where it's just waiting for, continues to check like, okay, can I get the lock now? Can I get the lock now? Can I get the lock now?
Got it. That makes sense.
I'm just going to close this real quick. That's not cool. So let's see. Do we still have this? All right, cool. So here's our back scroll with our watchers. So we can see that the first thing is this happened, I don't know, 5 minutes ago now at this point. Curity noticed that node 2 needed to be rebooted. So it coordinated drained the node and waited. And at some point it will have. So where do we have the final? So finally, this is a little bit out of order, but that's fine. The watch events aren't guaranteed to be in strict order. So once this came back online and was ready, it uncoordinated it, and then the reboot for VMSS3 for this one right here was then allowed to be processed. So you can see that transition here, and then eventually this also went ready.
Oh, wait, why? I'm saying why. My question is why node 2 shows 2 days and 23 hours. So you see what I'm.
That's a different node too. Sorry. So.
Oh, okay.
So there's actually, so if we look at, I'm gonna show you some cluster API. Maybe you aren't familiar with this. So, but I'm using cluster API to actually manage this AKS cluster, and so I've got 3 pools here.
Oh, I see. So it's a different pool. Yeah. Okay.
That's right.
Yep.
So yeah, very clear as mud, huh?
Yeah.
But what I wanted to demo and wasn't able to pull together with automation quickly enough was to show that. So this is the 3. When is this going to come? So once this comes back online, what you want to see as a user is you want to see this rev to 1089. So I'm not sure exactly why that unattended upgrade didn't get that. It's possible. I don't know how much more time you have. We can maybe wrangle this into place one more time.
Yeah, it's up to you. I mean, whenever you can.
Okay, well, just if we can get this for posterity. Where do I have those commands? Here. Okay, let's go back to 2. And so this one's back online. I ran unattended upgrade. That was probably not sufficient. So I probably need to do apt get update. So this is going to pull available packages. And so probably this hasn't run since this node came online. And then unattended upgrade had no work to do as a result. So if I run this now, again, we're on 2. So let's go back to our watcher here. I'm going to clear the scroll back. Pool 3, node 2. This definitely seems like something is happening at this point. So typically, another key problem that's being solved is it can be challenging, especially if you have, say, an environment with like hundreds or thousands of nodes, to really distribute these upgrades over time. And so typically what you'll see is, say in a period of a half hour, all of your nodes need to be updated. And so one of the key things for CureD is to be able to roll through that one at a time. Like you don't want to just refresh your entire node pool.
Yeah. No, that makes sense. Well, I don't think you could Kubernetes scales to hundreds of thousands of nodes, but
it definitely scales to thousands. If you meant hundreds of thousands, that's challenging.
Yeah,
that'd be a fun project. But I've worked on scaling it to thousands. It requires, operational tuning for sure, but it's fun and it's possible.
Yeah.
Okay, cool. So here we go. So that I just had to be patient and do this correctly. And so node 3 again, sorry, node 2 in pool 3 has now been marked for reboot in the way that I originally wanted it. So what I want to see now is I want to see this node when it comes back online. I want to see this rev to 1089, and that's the sort of canonical use case, I think. So it allows you to make sure that your nodes are always on the latest patch, getting the latest patches, and that your workloads aren't being disrupted. So a more fully baked demo would see, you could install some sort of vanilla production applications and watch the workloads gracefully transition from one node to another, and do a little fun like Towers of Hanoi process throughout the entire node.
Yeah.
Update enumeration. Okay, beautiful. That was actually quick. So pool 3 node 2 is now on 1089. It was formerly on 1086. Okay.
Awesome.
Cool.
One question is that, so you run as a daemon set, so there's a CureD process for every node, right? So
that's exactly right. That's exactly right. So if I do well, I'll just get the daemon set. I think it's in default. So yeah, it's on all. If I get nodes.
Is there a controller? Do you have a controller that, or are they actually, they just operating?
Nope. Yep. The sort of necessary synchronization in terms of communication is handled via that annotation. Like really the only thing that Curity needs to worry about is making sure that only one of its nodes goes through the reboot process at once. And so it uses that annotation against the daemon set
Got it.
as the sort of traffic cop to make sure that only one is actually doing work at once. But in terms of the nodes checking locally for var and reboot required, that's happening continuously and independent of any other node.
Awesome.
Cool. I
Cool.
can show you other things, or I can talk about the CNCF story for CureD.
Yeah, that'd be great. Like, what's the community like, and you're planning to, or you're submitting the project to Sandbox, and
Yeah, right. So I would say
mean,
the main reason that the CureD maintainers right now feel like it's appropriate to donate to the Sandbox is that the project has become pretty boring and stable, which is a good thing. And I think that we would like to reach more of the Kubernetes ecosystem. There's a decent, I mean, I don't have numbers. I'm not like sort of PMing the CureD project.
Yeah.
But like, if you look at your silly like star count and all that kind of thing, as far as over the last 7 or 8 years working in the Kubernetes ecosystem, CureD is, if there is a single tool that does this is the one. And I think putting it into CNCF Sandbox will sort of further reinforce that reputation that CureD is committed to doing this one thing well. And it's kind of going into a place where it just, in order to make sure that the existing user community continues to feel confident in the forward progression of the project in terms of like security best practices and ensuring that it continues to move along at the speed of Kubernetes releases, it seemed like it would be most appropriate to broaden this outside of the original Weaveworks sort of patronage. And the fact that I'm here from Microsoft is somewhat of an example that the original like Weaveworks set of maintainers has moved on to other things.
Yeah.
And I think I would consider myself an example of a sort of user advocate where CureD is super important and I want it to stick around. I want there to be a single tool for things like this that have one purpose. So as long as I'm maintaining CureD, that's one of my sort of most important guiding principles, is just to protect that aspect of it. There are a lot of things you could sort of evolve CureD into doing, but I think it's better for Kubernetes that it stay as simple as possible and as stable as possible.
Yeah, and how many maintainers do you have? Do you have, so you're from Microsoft, there's Weaveworks, are there any other orgs that are actually?
So right now there's 3 active maintainers that manage regular releases. The feature velocity right now is somewhat slow. And this is potentially also a justification to give it to CNCF, is to, by broadening the sort of visibility of the project and also kind of advertising that it's definitely an open source community governed project, that with the help of the Kubernetes community, we can determine if CureD feature velocity should sort of re-accelerate, or if it should be really a maintenance project that is sort of a core part of the standard Kubernetes toolkit like other projects. And we just want to, with the CNCF's help, ensure that the security story maintains viable, that we're always at the latest Kubernetes release support, all that kind of thing. There are 2 emeritus maintainers that occasionally will pop into the dev meetings, but largely it's not quite as quiet as say this meeting between the 2 of us, but a lot of the monthly dev meetings are just like 2 or 3 or 4 people.
Yeah. Sounds good. Uh, it sounds to me like the project is really stable. Do you have several end users now besides Microsoft and the other
Yeah,
company?
I mean, definitely, yeah. I would say, I mean, I may have put some of this into um, the proposal language that I filled out a month or so ago.
Yeah, for the application.
Yeah, I'm trying to, let's see.
Yeah, I'm actually thinking about next stages for the project, because once you go into sandbox, what a lot of projects are thinking about the next step, which is incubation.
Right,
And then when that comes up, things like how many end users you have, do you have, the maintainer diversity, do you have like the right set of dev stat tools, and so there's a variety of different things of which are documented on the TOC GitHub repository.
right. So my view is that I think that the CNCF sandbox will be to a certain extent, a kind of existential test of CureD where it should end up. My read, if you look through the commit history, most of these, there's a slight exception with recently as it's in maintainer status, most of the commits are from myself and then a couple of other folks from Weaveworks. But over time, I think the commit history tells a story that it's a project that isn't really Weaveworks specific. And I think that the folks who use it really rely on it, and it would make the most sense for that to be a standard Kubernetes tool. But I do think that as you sort of hint that in order for it to like, the reason you go to sandbox is to go to incubation. And I think that the incubation path wouldn't really make sense if folks just don't care enough about this. And
Right.
I think that the only way to answer that question is to go to sandbox and do some advocacy work. So that would be something that certainly myself I would commit to doing. Because for me, based on my experience with CureD and the ecosystem, the best place for this to end up would be, imagine like one of your favorite Linux tools that's just super simple, has a fairly static interface contract and just works. That would make the Kubernetes ecosystem better. I think if CureD were just the bog standard way to enforce safe, automatable, regular reboots on nodes. I mean, it's kind of not a very sexy thing, but for the folks who build, I mean, it's part of. I was hoping to demonstrate more automation because I think that's the way CureD is used in practice. Is it's part of a set of tools, and my bias from, I keep bringing up all these Unix tools, but that's definitely just my bias. I think that by having sort of well-scoped, super reliable, stable tools that can be composed together into different solutions, that whether it's Kubernetes or Linux or whatever community, really, really stands to benefit from future innovation by just having those tools do one reliable thing, and you can use them in flexible ways and sort of push the platform forward without having to reinvent everything.
Yeah, sounds good. I mean, just to give you some context, I mean, there are some sandbox projects that are remaining sandbox like indefinitely, and there's some that actually want to continue to grow and become more incubation. So I mean, it really depends on the project too, but just those requirements are there documented for incubation. So like, and there's, I think, a TOC sponsor that needs to be in charge, or basically comes forward and they like the project. So so that helps with the maturity of the project.
Yeah.
But yeah, I mean, I think it's the fact that it's stable. I think it's a good thing, right? So because like what if you look at the graduated projects in the CNCF, they're all like, you know, sort of stable, like they have a constant release cycle, and they do have a lot of maintainers, and they're actually being used by a lot of end users, right? So but I think it's a good step that is something that is actually, or it's a good thing that it's doing something unique and it's doing something well.
Yeah, cool. I mean, I'll add one more thing that that's a possible prediction of like feature evolution, and that is different OS support. So specifically Windows. So the var run reboot required assumes some sort of, you know, Linux. There are more than one kind of Linux. So you can have you might have a slightly different story for immutable OS type platforms like Flatcar. But Windows is a really different beast, and there is no, so because I work at Microsoft, I have a little bit of a window into this, and some folks that I do work with have prototypes what CureD on a Windows node would look like. But it's definitely interesting because it's taking a Linux concept onto Windows, and so the more standardized CureD becomes in the Kubernetes ecosystem, it could actually help to standardize this as a sort of prototype interface for Windows, generally speaking. So the question is really like, how do you mark a Windows node as needing a reboot? There's not really a single answer for that because Windows just doesn't do things in the same way as Linux. Mm-hmm. You know, there is some sort of like standard registry key identifiers that you can use, but it's not standardized in the way that var run reboot required is. So the better CureD is, or the sort of further along its CNCF path CureD can become, it can then positively influence a sort of general agreement about how that works. You know, CureD can basically become an implementation of a sort of proposed spec for how to mark Windows machines for reboot. So that's a possible feature evolution. And then just, you know, in terms of, even though the project is boring and stable, keeping it that way is non-trivial. You have the Kubernetes release velocity, but also just as things are going to evolve over the coming, say, 5 to 10 years, there will be more and more interesting things happening under at the OS level, and you know, super critical to get those exactly right. And so it will require, you know, a small set of folks who care about that kind of thing. You know, those sort of heroes who don't.
Yeah. Have you actually talked to the Kubernetes community? There's a separate Kubernetes community, right? And then they have different groups, and I'm wondering, like, if also long-term this could also become part of the core Kubernetes. But I'm just kind of
yeah, that's certainly possible. I think it's definitely premature for that. Like, yeah. I think the sandbox process is itself a super important one, and I want to respect that and just really focus on what that takes. And if there are gaps, you know, that's something we want to know about and maybe address. But if this is ready for sandbox, then I think let's just focus on that for now.
Okay, yeah, sounds good. All right, so you've already applied, right, for sandbox?
I believe so, yes.
Okay, yeah,
I think the reason you reached out is it sort of, after the application process, it got bumped onto a list of.
Yeah, there's a spreadsheet. So as far as, yeah, I think I found you on the spreadsheet. It's on CNC sandbox.cncf.io.
Yeah,
that's great.
Well, cool. Well, hopefully this content is informative for other folks looking at it. Yeah, and will help to, you know, get the right folks the information they need. And definitely reach out to me anytime. On you found me on GitHub. I'm on Slack. It's Jack Francis on Kubernetes Slack.
Yeah, likewise. If you need any help with the process, feel free to reach out. I'm also on Slack, and I'm also on the TAG-Runtime Slack channel on the CNCF Slack. So any questions that you have, or so I'm happy to answer. We also have some TOC liaisons, so Dim's, and I
Yeah.
think Richard and somebody, Ricardo Rocha. He's one of the co-chairs
You got a lot of Ricardos.
Yeah, so yeah, like he's one of the co-chairs for the next KubeCon.
Okay.
But we're in contact with them, and any questions, then we can relay, or I mean, you can chat directly with them too as well. But we're here to help out, basically.
Okay, great. Sounds good. I think what I'll do is wait, like say maybe early mid-September, I'll reach back out and ask for status if I don't hear back. Otherwise, I'm happy to just let the process play out for at least another few weeks, and then I'll bug you after that if I don't hear anything.
Sounds great. All right.
Okay. Thanks so much for your time, Ricardo. Thanks for putting this on the schedule.
Yeah. Thank you very much. Thank you very much for the demo. Okay.
Okay. Take care. Bye.